Okay, first, thank you so much for inviting me. I am super happy to share some of the algorithms and AI that we are applying to improve or to illuminate the underground with multimodal algorithms. But in the same time, I decided to show you more about like the cycle or how to create an AI product using this case of use. That is why today we are gonna explore from create the problem to go to production. But in the meantime, when we talk about AI, I am gonna show you some of the SLAM algorithms, computer vision algorithms, GIS data that we are using to improve the quality of our models. Really quick about me, my name is Adonaí Vera. I am based in Colombia. I have been working in multiple projects, and in the last years, I create two companies in Colombia. One was about accounting process, and the other one was about the Google Analytics for the physical world. But I am not gonna talk about that. Right now, I am working at Subterra. I am a machine learning engineer. But yeah. I would like to start with something that I always add to all my presentations, and it's the reason why I am here. And I always explain this because it's important for me. And on the left, you can see my father. On the right, you can see my mom. And they were like 6 or 7 years old at that time. Right now, they are like 17, 65, I think. And for me, it was super hard to just think how they move, how they think, the way that they express, the way that they look, all of these movement that they can do. Because I don't know you, but in Colombia, usually we have a big photo album with many pictures of us, of our parents or wherever, but we don't have a video because at that time that wasn't something normal. Suddenly, an AI algorithms, a GAN, and I know it's not the best one right now with all the diffusion model, we can create amazing things. But for me at that time was something super nice that you can take a picture and create movement. And I say, wow, this technology actually is gonna change the way that the world is working right now. And I would like to be part of that. And I changed my purpose and I decided to create easy technology, like easy to use technology, accessible and with good quality to everywhere. And I just let you know this because it's part of my story and how I finished working in AI algorithms. Yeah. But today, like I said before, we are not gonna go only to the research. The research are super good, but I would like to give you a big pictures. Like not only create the model, but how we can put this model on production, how the people can consume or can use this model in a real environment. Because sometimes we just focus on create the models, and that's fine, it's super fine. But we have to think of how we can put this on production, what is the real problem that we are solving, and all of the steps and problems that we can have when we are creating a computer vision algorithms. That is why, like always, that's gonna sound like a pitch, but like always, we have to start with the problem, and I'm gonna show you the problem that we are solving, but I would like to give you an advice and thing that I learned. And one of the first things that I learned was AI is not always the solution. And I think many people know that, but to say the truth, when you are in love with a technology, just saying an example, stable diffusions, we use the technology and then we try to find problems, and that's fine. But I believe that we always have to start from what is the main problem that we are solving, what is the thing that we are working on, or what is the pain of the user. And I believe that if you want to find a problem, you have to identify, of course, that problem, analyze them, and check if there is other solutions or if you can validate it with real users. There is a phrase that I love that is from Yuri Levine. I don't know if I am pronouncing correctly, the founder of Waze, and he said you have to fall in love with the problem, and I am totally agree. We lost a lot of time because we have a good technology and we just try to fit it in some place where actually the problem doesn't exist. That is why that's something important. In our case, because this is a technology meeting, I have to show you a real case, but this is the problem that we decided to work. And it's a problem that is happening around the world. This was in Maharashtra, And it was someone in a motorcycle, and then the street just something happened there, and the water and everything was super hard. And of course, there is a dangerous with the person that was in the motorcycle, but just think how much they have to spend to fix that, just to fix it. Why, if we maybe can create algorithms that avoid to these kind of scenarios, and instead of that can predict when these things could happen and solve it before it happens. That was the idea of our CEO. He decided to work in that, Robert Lee. He decided to create technology that can solve this problem. That is, why if we map or digitize the world? Why if we use AI algorithms, computer vision algorithms, object detection algorithms to find when and where this kind of situation is gonna happen? And this is the first step, the problem. But then we have to move to the scope. And this is the same when we are working in research. The research question or the problem or the scope that we would like to do or we would like to achieve, it's part of this scope. And one thing that I learned was always create minimum viable products, MVPs, to help you to validate the main idea, and then jump actually to improve these MVPs, but always trying to focus on what is the priorities or what is the must-have that the algorithm has to have. What is this thing that the user actually can solve the issue? And then you can think of maybe it's something nice to have, or maybe something that the algorithm should have. But if you focus at the beginning of what is the most important thing that the algorithm has to have, you are gonna reduce and you're gonna save a lot of time. I know that this sounds like more an entrepreneurship talk, but we are gonna go to the code really soon. This is just, I would like to give you the big idea of how we finally create the models. In our case, we decided to map, analyze, and forecast risk. And the first challenge that we got was, okay, what about the data? How we can get data? How we can collect data that can help us to do this? And there are many ways to do it. I am from Colombia. There is a page here that you can use to find information about many things. But there are other things, other ways to find data, Kaggle's challenge, the Hugging Face, repositories, open source data set. My advice here is not start to create the database from zero. Before you should check what is right now in the state of the art, what is the latest data set that you can find, and use that as a way to create your first model. This is more about the data. Just in our case, and give you more context, before us, the way that the people do that, they have to go to the pipe, they have to go to the sewer, and they have to make this inspection in person. Or there was another solution that was with a big robot and go through the manholes and through the pipes. This is more about the problem, no? They have to go to understand what is happening underground. We just decided to create a small device, super small device. And I love the first talk about omnidirectional because we used 360 videos to do this process. We try to make it the cheaper possible, just a robot with a GoPro camera, a GoPro Max camera that can get all the information around the environment. And this, if you have an idea of you are working on a project, this kind of source of data has many challenges that you have to work, but at least was a good way to collect all the information of the environment, like the 360 image. You can move around the place and you can start creating algorithms and information that can help us. But this was the way that we collect the data. This was the way that we start to get information. And one advice that I got a couple of years is you can go to open source libraries and you can get data, that's fine. But you have to think how you can keep collecting data. Like today you have this data set, but how you can keep getting more data from the user or from the inspection in this case. And that is gonna make the difference between the competitors. Just think, that's one of the reasons I believe that the company has to find a way where they can keep collecting data, and it's about the mode. Before, the people or the castles has some water next to the castle, and that makes that the people or let's say that the people that want to go to the castle, it's gonna be harder to go inside because there is water, and sometimes they put dangerous animals in that water, and sometimes just because the water they can't use big machines. And this is something interesting because if you create a big moat, you can make that your competitors make it harder to copy your business idea or to copy your model. Right now, all the models, I believe, are super replicables. Like you can go to a research paper and you can like try to replicate that, and you can make some adjustment and you can create a new algorithm. But the real challenge is how you can increase the mode. And I believe one of the ways that you can do to increase the mode is with data. If you have quality data, if you have data that it's clean, or you can find a way to clean that, or if you can find a way that you are collecting the data, that's going to be a big difference between the competitors. Today, if a new company starts, I can use a open source model, a pre-trained model, and fine-tuning something to make it work. But the data, it's a process that takes time. That is why if you are working in a project, another advice that I think is super important for me at least, it's try to create a way where you can keep getting the data. And when we talk with data, we have to do all this process that is understand your data, clean the data, labeling the data, to know how to keep increasing the data, and of course, connect the data with your model. This is part of the pre-processing step. And now, finally, we are in the models. Let's talk about more about models. That is the most important thing. We have to think how the user is going to use this model. It's going to be in real time. The user has to consume the model in real time, or maybe could be something that they make the inspection today and they would like to see the data in a couple of days. And these different scenarios is gonna make that you can find what is the best model for your case of use. You can maybe use a heavy model that takes more time to make the inference, like to make the prediction, but because your case of use tells you that you don't have to do it in real time. I remember that I created a project a couple of years ago that was a drone with a camera that tried to find birds, like the birds, and try to track the birds and like simulate sounds. And that was trying to reduce the risk in the airports between birds and airplanes. And in this case, the real-time solution was something super important. Doesn't matter if the model has false positive, I have to focus on make that the model works super good. And in our case, the first algorithm that we integrate was a SLAM algorithm. But I told you at the beginning that we use a GoPro camera. That is why we don't use a LiDAR. And we still need to get 3D data. And why it's so important, the 3D data, and this is going to be our first source of data. We are going to talk about multiple sources of data to create a multimodal algorithms. But it's important, this 3D object, because you can find defects in the shape of the infrastructure. That is why the LiDAR is going to give you really good results, but in our case, we would like to create something cheaper. We decided to use traditional algorithms to find and to geolocalize the object. And the way that this algorithm works, thinking just in a business idea, is, let's say that you find, let's use this as an example. Let's say that you have your camera and you find a point, this ball, and then you go to the manhole, and then you find the same object, and now you have two different perspectives that is pointing to the same object. Then you can go down and you can find again this balloon, this soccer ball, and you are going to have three different perspectives of the same object. This kind of triangulation is going to help you to create the 3D object without use a LiDAR. Yes, of course, we have drift, we have scale issues. We don't know the exactly dimension because we don't have depth. But this is going to give you the main idea of the infrastructure. And this is the first the first source of data that we use. But there are more. Of course, we are trying to analyze on-the-ground inspections. We can use the object detection algorithm. This is the equirectangular image. In our case, we decided to move. I remember that the professors in the first speaker told us about you can go to split the 360 video in subparts, or you can use the equirectangular. In our case, we decided to use the equirectangular image, and we decided to train and to make the leveling on all the steps using this information. And what was what was the main idea of the model? Find information about connections, steps, defects, the size of the connection, all of this information that can help us to take better decisions. And right now, we are using the same video, but we are creating a point cloud, and we are creating an object detection algorithm to find connection defects and more information. Right now, we are using the same source of data, but for two different purposes. Okay, then we can keep integrating multiple algorithms, and that's fine. For example, we can use that to find or to apply segmentation algorithms, to find joints, to find the water level, to find information that are directly in the database, using the same idea of how we can go through the manhole, in this case through the pipe, and we can level in these objects, joints, and other kind of things to improve the quality of the reconstruction. That was like the number three models that we integrated. All of them are working together, like the 3D object, the object detection and the segmentation are working together and help us with something super important, and is that when you find a defect or a connection, you can go through that connection. Like you can go actually to the 3D object, going from the 2D to the 3D, making the transformation, and get information about the real place that is the object. This is a view, this is an image of a 3D reconstruction. Of course, a dense point cloud, not a sparse point cloud like the other ones. Here it takes more time, use more like a photogrammetry algorithms. But here the idea was how we can not just get the image, but in the same time get the 3D object and correlate image and an object. And everything, all of these algorithms are only in the model step. Like we move the problem, the scope, the data, and now we are in the model step. And here we are integrating multiple models. The solution is not only one. We have to track, we have to keep tracking, we have to testing to see what is the best solution in all the scenarios. And here I start to make it like more interesting. We can use algorithm as well to find the speed. Using this, finding this feature and tracking this feature on the time, you can know the speed of the robot when it's moving through the pipe. Here we are using another algorithm. Look at that, we are using multiple algorithms to make a better prediction. We can use GIS data as well. We can use this GIS data to know the position and what should be the route before actually go through the pipe. Before make the inspection, we can do these kind of scenarios, and we can as well create and replicate how the algorithm, how the object move in the real world. Just to summarize here, 5 different algorithms working together in the same source of data. We have the GIS data, that is another one, and the information that the user give us, and the sensor data. The sensor data is the data that we can get, accelerometer, gyroscope, but all of them are working together to give us information about the inspection. And this is only for the model, because after we get all of this information, and not only today, but just think that we can make an inspection in the same place a couple of times, we can start to getting difference between the objects today and difference between the objects in the last year and how they are changing. And with that, we can create prediction algorithms, not only to find what is going to be next, but in the same time to measure the difference between one day and another one. This kind of prediction can help us a lot. And this is an installation machine learning model, or the results of an installation machine learning models that we can use to find defects in the sensor data. That is another source of data. Something important to say here, at the end, you create like a laboratory with the users, when the users can give you feedback and you can improve, or you can make change, or you can like see if actually the water level is important, see if actually detect the joint is important, and you have to keep improving the models. But after here, until here, you create a model using the data and based in the real problem. If you are creating a company, or if you are working as an AI developer, I believe that you have to know all the flow, all the steps that make that the model works on production. I remember one case that was something that we didn't plan. What happened when the robot, just the camera get or the water just put on the lens, and that's gonna make that all the model doesn't work, and this is gonna be a big issue. We can use GAN algorithm, the first algorithm that I showed you with my parents' image, and you can remove that raindrop on the lens. Let's say that can help us to improve the quality. It's not completely remove it, but it can help us to improve the results just applying algorithms that actually we found when we went to the real environment and put this robot to work. And we can still creating more and more algorithms to find if the robot stop, or algorithm to find if what is the water, what is the wall. All the information that you need, you can get it directly from the video and from the image. Yeah, until here we create the product. We say, okay, we have the best product, looks super nice, the user love it, and the user start to give you feedback. And one thing that I learned is that the user is gonna always give you more and more things to create. Like, you have to do this, you have to do this. And if you start to collect all of this feedback, that is good. You have to create a laboratory. You have to know what is happening. But if you start to use that and just put it on develop without thinking a roadmap, that's gonna make that you lost a lot of time. That is why it's important to you create like a roadmap where you can get the feedback from the user, put it in the roadmap, and just like try to work in the most important task without lose the focus, without lose the main idea of the problem. And one idea could be go back again to the MVP. Just think what is the must have, the should have, and the nice to have of your model, and that is gonna help you to actually find what is the priority for your product. And yeah, I know that it's more technical, but I believe that all the developer has to know more about what is happening around that, because the ML, it's only one small piece of the big infrastructure that could be develop a product. We're talking about which in what place is gonna work this model. It's gonna work in a Jetson Nano, if someone is working with hardware, in a Jetson Nano directly on the robot, or it could be in the cloud, or it could be in a local computer, or directly on the page. These kind of questions is depend on the case of use, but you have to start thinking that the ML models, just create the model is a small step in this big picture. You have to know how you can track your model, how you can improve the results of your model, how you can retrain the models. In our case, we decided to use the cloud because the user doesn't need information in real time, but that's gonna depends. If you remember the example that I did with the drones, in that case, I need to run everything in a Jetson Nano, in a NVIDIA graphic card, and I need to make it faster. I need that the algorithm works good and give me good solutions in real time. there are many things to deploy these things. Like you can use AWS, GCP, or you can use actually a special device to do this kind of deployments. And yeah, finally, I just want to, if there is someone that want to create or work in different projects, I believe that there is some advice that I would love to receive when I start doing this, and was be part of the community. This kind of a space that Jimmy is creating and all the Voxel 51 team is creating, it's amazing because you can start to know more people that is working not only in research, but in the same time in big companies. And not just creating research, as well creating applications. That is more like the thing that I try to do today. Take advantage of the programs. At least in Colombia, there are many programs that you can go and you can use, and sometimes that the people doesn't go because they don't know or they don't search about that. If you are in a university, of course, it's obviously, if you are doing a PhD, you are doing research, but if you are maybe doing a degree, or it's fine if you can from day one go to the research team, trying to find a laboratory, try to find a place where you can explore and create things. Get a mentor, get courses, learn win projects. And one of them, the latest one, and with this I'm gonna finish, is if you can work in a startup, in a company that is growing, that is starting, that is tech based, that is going to be one of the best learning that you can get, the best school to learn that you can get, because when you are in a startup, everything is moving super fast. Today you are creating something, but tomorrow you can start doing totally different things. Like these scenarios when the user just let us know that this product is cool, but maybe if we move to another task, it's gonna be better. This kind of movement between the tasks, it's something that is gonna help you a lot. And finally, contribute to open source project. I didn't say before, but I contribute to 51. I contribute to supervision libraries. I contribute to Keras. I contribute to multiple open source projects that I believe is a way to return some of the amazing things that we learn. Thank you again, Jimmy. Thank you again. Jacob is not here, but thank you for inviting me as well. And thank you for the team. If you have any question related to the algorithms or maybe to create companies, I am super happy to answer any questions.
Fantastic. So we do have two questions here in the Q&A. Maybe I can prompt you for the first one. My question is more generic. If I needed to make more complex models than even existing proprietary models, does it mean that I should have access to data and compute than the proprietary organization? I'm not sure I follow the question, but maybe you do.
Actually, no. Let me read it again. Okay. Okay, yeah. You mean like the traditional algorithm, the pre-trained model doesn't work for your case of use, and you want to go further. You want to actually create more robust models. And for me, I believe that if you are in a big company that can spend time and can spend money to create models from zero, it's gonna be fine. But if you are in a startup, that's my tip. I don't know, that's my perspective. It's better if you can use that big pre-trained model and trying to fine tuning. You can play with this infrastructure using the base code, and you can start to see what works best for your solution. You can make a fine tuning, change variables, change configuration, hyperparameters to find the best solution in your case of use. I believe that is that. If you have a big company, of course, you can spend money to make only research about how to improve the infrastructure and do more of these kind of things.
And it looks like we have one final question here from Nicholas, if you want to take it.
Yes. Okay, say, how do you determine when the model algorithm is good enough for use, since accuracy is important in these kind of situations? Yes, I believe that the first way to do it is put it on production. Like you can create the best model and you can check the accuracy. And actually with the new models, YOLO version 9 and YOLO version 8, YOLO Word, YOLO NAS, in numbers, they look super nice, super nice. But you have to take this model and actually test it in a real environment to see how is the performance. That is why I believe that you have to put your model on the real environment from version 1. You don't have to wait to have the best version because you are gonna lose time. And just to let you know, I am working in something that I would like to share because I believe that compares model is important. And actually, I am using one of the plugins that the Voxel 51 create, the 51 team, and you can compare multiple models, but not only with traditional data set. Actually, you can upload your data set and see how is the performance, if you have the ground truth, how is the performance of the models, multiple models, with your case of use. And then you can see what is the best solution. But the short answer is for try to go from the first version to production to see actually how good is the model, and then try to improve the results.